Hey, good afternoon, everyone. So for today's quote of the day, you can revisit back if we if I move on from it too quickly. It's something you really just have to read. You can't really say it out loud because of what that some of those words mean. So so just thought I'd throw a little humor out there. All right, so let's see. Not sure why there was a second meeting going on. I didn't start that other meeting. I don't know if someone else did, either on purpose or by accident, but we're on this meeting now, so make sure you join up here and we'll get right into it. So today what we're going to do is we're going to do some slides on interfaces. I don't know if we'll get through all of the slides today, but it's okay because I'm looking at the schedule and looking at the syllabus schedule, and I did throw in this possible Ramazan Bayram week next week, but it is I'm thinking unlikely that we'll skip both classes next week. But what I will do is I will do a midterm review next week as part of what we do, and not positive yet, but possible that you may get a quiz next week. So I know I don't ever announce those in advance, but that's all based on whether or not I can get the quiz made in time to give it next week or not. So so a little heads up from me to you. Maybe it's because of the holiday coming up. I'm feeling extra generous. I don't know, but you're probably like, extra generous, what? Anyway, so let's move on. Interfaces. All right, so we talked about abstract classes last week, right? Or not yesterday. We talked about how we can have a class that we can create a variable of that type, but we can't create an object of that type. And one of the things that it's useful for is for controlling when we want to define a class of things that share some things in common, but we don't really have there's not a real solid thing that thing could be. And what I mean by that is, for example, the geometric object, right? We talked about how you can have this idea of what a geometric object is, but really, if we're going to say, I want to have in my hand or on the paper or whatever, something that is a geometric object, it has to be a specific type of object. It has to be a circle or a rectangle, or we talked about square also yesterday, right? I hope you guys looked at the lecture examples from yesterday. Also, because another one that we talked about was person, was how to create an abstract person. But that when it comes to maintaining information in the university database, nobody here is just a person, right? Every person in the university system is a student or a teacher. We didn't get into employee, but you could have employee. These are all things that they could be, right? So that's how abstract classes work, okay? An interface is a little bit different in that an interface is not a class. An interface is like a class, but you don't inherit from it. Okay, so one of the big differences between an interface and a class is a class, abstract or not, can have non-abstract methods. Okay, an interface can only have abstract methods. The variables in an interface, the only types of variables that can be in an interface are constants. But so if basically an abstract class is trying to define some of the common attributes or some of the common things that other classes of its type are, what they are, kind of defines what they are. Interfaces, the commonality amongst interfaces is more like behavior. Okay, so for example, some interfaces that are common that are already done, we'll talk about, are comparable, Edible, we'll talk about an edible interface in just a moment. Clonable. So notice the able, or I guess in Turkish that would be abilir or ebelir, right? So it's comparable, it's able to be compared, it's edible, it's able to be eaten, it's clonable, it's able to be cloned. So we're trying to say anybody, any class that not extends, not inherits, but implements, that's the keyword we're going to be introducing today. I'm going to type it right here. Implements, right? Implements an interface. We extends to a parent class, abstract or otherwise. We implement, we use the implements keyword to say that we're getting our abstract methods and our constants from an interface instead. Okay. There can be some useful things here. Okay, so for example, we, instead of saying class, we call it an interface instead. We use the interface keyword, we give it a name, we give it some constants, we give it abstract methods, right? So for example, if we wanted to create an interface called edible, so any class that inherits, that implements the edible interface, we're saying it's an edible thing. It's able to be eaten, so we're going to give it a method of how to eat. Okay. Now notice that again, this is an abstract method. All methods in an interface are abstract. If we try to put a non-abstract, a concrete method into an interface, we will get a compiler error. So all of our edible things, there must be a way to eat it, right? Okay. So an interface is like a special class, all right? You can use an interface as a data type for a variable, so we can make a reference variable of the interface type as well. So if we wanted to make an edible variable, but we can't make an object of that type, an interface has no constructor. Again, there's no concrete methods, right? So we can't create an object of that type. We can create a variable, but anything that, but just like with the parent classes that we talked about before, if we create a variable of an interface type, whatever object it points to has to implement that interface. Okay. Also, let me introduce some new symbols for our UML diagrams here. Okay. So before the inherits through extends, this was our extends notation here, right? Where we are saying that a chicken is an animal. So all common traits that animals have, right? We're going to have them as part of this class, this abstract class animal. So all animals make a sound. Maybe, I mean, maybe not all, but you get the idea. So we're going to say that animals in our system all make a sound. A chicken makes a sound, a tiger makes a sound. If we had one over here, what's another good animal? A giraffe. I don't know what sound it makes, but it makes a sound. An elephant. If you go back a number of years to a popular song from like a decade or so ago, if we had fox over here, what does the fox say? I don't know. Right. Okay. Now over here, this symbol here, yeah, I'll let you try that. You let me know how that turns out for you, Metahan. Okay. All right. This way of drawing, notice it's a dashed line. It looks similar. It has a triangle, right? But it has this dashed line instead. That's indicating that this is an interface and this is implementing that interface. Okay. So this is implements. and this is extends. Okay. An interface edible, so some things are edible. Now notice that a chicken can get information like an abstract method, like how to eat and sound, from two different places because it is both an animal and it is edible if you're not a vegetarian, of course. But we'll if anyone in the class is a vegetarian, just bear with us for this one, okay? All right. So this is a way that a chicken, or that a class rather, can get things from multiple places. Okay. Remember, I can only have one parent. I can only extend one thing, but I can implement many things. So I can implement the edible interface, it can implement the comparable interface, it can implement any other interface we decide to create. Now on the other side of this, we have a fruit. Now notice fruit is italicized. What does that mean? It's italicized. What does that mean? Italic. Is it italic? How do you say italicized in Turkish?
Hocam, we say italic.
Italic?
Yes.
All right, so what does that mean? The fruit is what? What do we know about the fruit from the fact that it's italicized? Anyone? Right, it's an abstract class. And notice its children, orange and apple, are non-abstract. They are concrete classes. So what that means too is that fruit does not have to implement the how to eat method. It doesn't have to. It can, it just doesn't have to. Fruit can wait and not implement that method and say, you know what, I'm going to force my children to implement that method. Right. So it exists as an abstract method here because fruit implements that interface. It gets the how to eat method. If it doesn't implement that method, if it does not make that a non-abstract method, that's okay. No compiler error there. But orange and apple will both need to have a non-abstract how to eat method. Okay. All right. The nice thing about interfaces is that because all of the constants, all of the rather variables are public static final because they are constants, and because all of the methods in an interface are public abstract, that means we actually don't have to include these modifiers here. Okay, so this is not necessary. We could write it this way and automatically the compiler will know this is a public static final integer called k. This is a public abstract void method called p. Okay, so we don't have to do that. Okay. All right. A very useful interface is the comparable interface. Now, what this does is it's an interface that takes an E. We'll talk about what E is when we get to generics. Okay, but we can compare two values to each other to decide which one is greater or less than, or if they are equal. Now, what the compare to method does is it's an integer method. So if the thing implementing this interface, if the class implementing this interface is considered less than the object that's being passed, then this would return a negative value. If they are considered equal, this will return a positive, equal to 0, value 0. And if the class implementing the interface compares to this other object, if it is greater than, then it returns a positive value. This is really an important method for the purposes of doing things like sorting things. We need to be able to figure out what's greater, what's less if we're going to sort things. So some of you guys have familiarity with the arrays.sort method. There's also a collections.sort as well, collection sort method. Both of these would require that whatever is being sorted implements the comparable interface. All right. There is another, it's not an interface, but it's the compare method in a special class that we can create. We'll get there when we, which week is that? I think it's when we talk about generics in a couple weeks. All right. But for now, comparable interface is the way that we can directly make this class, the class that implements this interface, comparable to other things. So for example, right, integer extends number. It implements the comparable interface because an integer is comparable with other integers. They don't show us the implementation, that's okay. But again, if the integer being passed is greater than the integer that is being compared to, this would result in a negative value. The thing I'm running the method on is less than the integer that's being passed, means it's negative. Big integer, also comparable. String, we talked about this last semester about how we compare strings, right? So we know that strings are comparable, dates are comparable. These are all things that we want to be able to make comparable to each other for the purposes of sorting and doing other things like that. You know, in fact, let's pull up this example. Let's see. Oh, I don't have JGrasp up yet. All right. Let's see. Let's do this. So let's look at the examples that they gave us here. Okay, so system.out println or integer. I'm just going to copy it from over here. Paste it into our JGraph interactions window. Okay, so what we're going to do is we're going to compare an integer of value 3 to an integer of value 5. We should get a negative value. Oh, it's I can include the semicolon because it's a print line. Okay. So -1, indicating that 3 is less than 5. Okay. Look at a different example. Okay. What value do you expect will display when I run this? Everybody says -1. Let's see. What? -2? Remember, compare to does not necessarily always return -1, 0, or 1. It returns a negative number if this is less than this. It returns 0 if they are equal, and it returns a positive number if the second thing is greater. Okay, it's not necessarily -1, 0, and 1. Okay, it could be anything. So the only thing you're checking is it less than 0? Is it 0? Is it greater than 0? That's the only thing we're checking in those. Okay. I think this might also give us a hint as to what the implementation of this looks like if we start looking at some other examples. Notice that as I increase this other one more and more, what happens? I get higher and higher, more and more negative, right? So that could give us a hint as to what the implementation of this is. What did we say this was going to be? Is this going to be -, 0, or positive? Is Star Wars less than, negative than Star Trek? Is it equal to Star Trek 0, or is it greater than? Is Star Wars greater than Star Trek, positive? Oh, positive. Star Wars is greater than Star Trek. So true. So true. All right. Okay. Let's see. Let's look at another example real quick. If I can get to the right tab here. Okay, so I'm going to create a date here. Two dates. One. Is day 1 going to be negative compared to day 2? Is it going to be negative, 0, or positive? Says positive. Sadhgi says positive. Thumbs up from someone. Let's see. Good. Okay. Question. Let's see here. Let's make a little modification here. And then, actually, hold on, let's just do it this way. All right. Now, which one is greater? Date 1 or date 2? Yeah, this one's tougher, isn't it? Why is it tougher? Why is this one tougher?
This one is tougher because we don't know which parameter is month and which parameter is day. We don't know which refers to which one. So
yeah, exactly. We don't know because we don't know the date format. We don't know. So And Americans make things difficult like all the time, don't we? And so let's see. But the answer to this question will tell us what the date format is, won't it? Okay, so it's positive, which means it's seeing date 1 as greater than date 2, which would suggest that this is year, month, day, right? So if we look at date 1, we should see in the date here, let's see if we can find where the information on what the actual date is. Do they not like? They don't give us the actual information here, do they? Okay. We could do, let's see. Oh, was it get month? Is that what it is? I don't work with dates enough. Let's see. Should be. Okay, it looks like a date. No, that's not what I want. Oh, does it not have a get month value? No, it doesn't like that. That's probably not right. Okay, I'll have to find out later. I don't work with dates enough in Java. Yeah, so what we determined was it is year, month, day. Yeah, which somewhat reasonable, right? Okay. All right, let's see. Let's move on. So that's the last of the examples there. Yeah, I don't, there's nothing else that I want to do up there. Okay, so I'm not sure if we introduced this before. I think we did. This instance of, yeah, actually we did, because this was from the inheritance lecture. All right, so if we use the instance of operator on a reference object, on a reference variable, we can tell if it's a class. We can tell if it's an instance of its parent, of a parent class. We can tell if it's an instance of an interface. All of these will be true. So n, that is an integer, is an instance of integer. It is also an instance of object because it is an object. It is an instance of comparable. It is comparable. Same thing with string here. String is an integer. Sorry, S is a string. S is a string. S is an object. S is comparable. D is a date. D is an object. D is comparable. Okay. So all of these will be true. So we can use the instance of operator to determine if it is a child of a specific class or if it implements a particular interface. And that can be useful for casting two things. Okay. All right. So here we have a geometric object, an abstract class. We have a rectangle, just a regular rectangle like we've done before, right? And we can have a child of the rectangle that is a comparable rectangle. Rectangle, as we implemented it before, was not comparable. We could not say, did one rectangle, was it greater than, less than, or equal to another rectangle? I think we did have the equals method to figure out if they were the same value, right? Maybe we could do based on the same area or the same something else, right? But the comparable rectangle, we're going to be able to say which one is greater, which one is less. But by implementing that interface, right, with a compare to method, right, then we get access to be able to compare those to each other. And then by having that comparison ability, we can then sort those rectangles. We can sort them from smallest to largest, largest to smallest, and we decide by implementing the comparable rectangle, by implementing this interface, in the comparable rectangle class is where the compare to method is defined. And we can set the rules as to what makes one rectangle bigger than another. Do we want to do it by area? Do we want to do it by perimeter? Do we want to do it by date created? Do we want to do it by color? All right. All of those can be ways that we can compare the rectangles to each other. And it's all based on what our user wants. It's all based on what what our customer wants. And so, for example, if I had a student class that was a comparable student, I want to be able to sort the students. I do that from time to time when I'm grading things or I'm looking at things. I sort students, right? And what happens? How do I sort them? Multiple ways. There's different ways I may want to sort them at different times, right? One way that you might be greater than or less than another student is based on your student number. I may sort them by student number so that I can enter information from maybe like a Microsoft form or something like that. Right. I might sort them by name because if I'm looking, because I don't know all your student numbers, like for example, the last few students here that have commented, Metahan and Mohammed Khan and Metat Sueda, there's a lot of names that start with M. Is that common in Turkey? If I were to sort you by name, that might be easier for me to find you in a list of students. Okay. What if I want to sort all of the students by their final grades to see who got the A's and who got the B's and who got C's, and let's hope that there's not too many down below that, right? I might do that. I might sort by final grade, right? So there's all kinds of different ways that I could compare students to each other for the purposes of sorting them. Okay. And we get to set the rules in the compare to method. Okay. All right. Let's see. Anything else specifically here? Let's skip over the clonable interfaces, and let's do a few things, a few comparisons here on the abstract classes versus interfaces. Okay. So abstract class, there's no restrictions on variables. We can have constants. We can have normal variables, we can have private variables, we can have public variables, we can have whatever variables we want. Interfaces, all variables are constants. They're public, static, final. An abstract class, we can have a constructor, right? But an abstract class cannot be created using the new operator. So even though an abstract class has a constructor, we cannot create an object of that type. We can only have a reference variable that points to an object of that type. Okay. An interface has no constructors. It's not a class. It's a class-like thing, but it is not a class, so therefore it does not have any constructors. Since it doesn't have any constructors, we also cannot create an object of a type interface with the new operator. But again, we can create a reference variable that of the type interface that points to a class that implements that interface. Okay. Finally, as far as methods, just like the variables, abstract classes have no restrictions. We can have public variables, public methods, private methods. We can have abstract methods. We can have concrete methods, everything. For interface, all methods are public and abstract. All right, so there are no concrete methods in an interface. Now, again, so using that, talking back to that instance of stuff that we were talking about, a class can implement multiple interfaces. An interface can implement an interface. A class could also extend another class. Okay. A class could extend a class that extends another class. A class can extend a class that implements an interface. Okay. So let's say that we have class 2. So class 2, if we were to say instance of object, true. Instance of class 1, true. Instance of interface 1.1, yes. Instance of interface 1.2, yes. Instance of interface 2.1, yes. Instance of interface 2.2, yes. Instance of interface 1, yes. And instance of class 2, yeah, true. So you can say, is it an instance of its own class type? And you'll get a true for that also. So it is, so class 2 is an instance of everything else, everything on the screen, including itself. Class 1, if we were to say instance of object or this, interface 1.2 or interface 1.1 or interface 1, yep. But if we were to say class 1, instance of interface 2_1, the answer would be false. It is not an instance of interface 2.1 because it doesn't implement an interface that implements that interface. It does not extend a class that implements that interface. Okay. Make sure you know which direction the arrow is going. Okay. Some conflict interfaces. If you have a situation where two different interfaces that you are implementing, that your class is implementing, have the same constant values, constant variable names with different values, or two methods with the same signature but a different return type, we can end up getting an error. Okay, a compiler error that will be detected by the compiler. Okay. So if you have two, so like in our previous slide example, class 2 implements this interface and this one. Each of them has a method in it, M1, let's call it M1. One returns an integer, one returns a string, right? That can cause a problem and the compiler will notify us. All right. Let me do one thing. We'll do an example real quick of something I want to show you guys. And then okay, just like what is that? Okay, so I don't have anything in there. That's fine. That's great. So let's say integer my int, string my string, int my method, my other method, and let's tell it. Let's give it a variable here. So now if I compile this, all right. Where are you expecting something? Oh, that's right. It's a constant, so I have to give it a value. My int equals 100. My string equals CSE. Okay, so now that works. Now, if I were to say, oh, you know what, but I want this other method. I want a void method called my other method that takes a string parameter. And what I want to do is I want to display something with this one. Simple hello world program, right? Now, if I were to compile this, I will get a compiler error. Right? Because this method has to be abstract. All methods in an interface have to be abstract. Okay, so abstract, compile, everybody's happy. Default keyword for what? For this? Yeah. But the default doesn't do that. But the whole point is that in an interface, you should not be able to, well, maybe, I think that's actually, it depends on the JVM, doesn't it? You're talking about like put it here, void. They allow these now. They allow method bodies in interface. Wow, they allow method bodies. So the slides are out of date. Okay. Thanks for bringing that to our attention, Conbert. All right, so interfaces, if you can use the default keyword to be able to give it a, I guess, a default implementation for others, which kind of, no, it doesn't make interfaces pointless, but I mean, we already had that with, we already had that with abstract classes. Okay, so, one other thing. And then I promise I'll let you go. So if I were to try to compile this, I should get a compiler error because we got methods over here. Sorry, my other method. We got methods over here that are abstract that haven't been implemented. Right? We have to. We have to make sure that we implement this. Right? Implement this method, and we should get another error, right? Because we didn't do this guy here. So now when we go to compile it, everybody should be happy. Oh, nope. Oh, okay. Privileges we consider has to be public. I have to explicitly say public. Okay. All right. So see, I implement these methods that are abstract, right? And now everybody's happy. Okay. All right. So I went over time a little bit. Sorry about that. Wednesday of next week, we will continue with our final discussion on abstract classes interfaces. We'll do a lot of examples on Wednesday, and then Thursday we'll have an exam review, and then the following week is your midterm. All right. Any comments or questions before we end for today?
May the force be with you.
Thank you. May the force be with you. All right. Have a good afternoon, guys. Have a good weekend.